Tom from Saint Gobain. This is the last chat talk of the day, and a little bit of bio from Tom. So Tom, you have a career data geek with rolling in data, statistics, data science, data engineering, and most recently machine learning with Saint Gobain. Saint Gobain, in case you wonder, French company, that's probably why I can say it properly. Saint Gobain. But sorry, just realized Saint Gobain is a world-leading provider in construction and building materials. So please welcome Tom for his last chat of the day. So please,
Thank
Tom.
you. Ironically, you probably know more about Saint Gobain than I do, because no one's heard of them in England. So hello everyone, how are we all feeling? Yeah? We enjoyed today? It's been really novel seeing people again, hasn't it? I've loved today, it's been fantastic. It's been fantastic to see so many of you. It's been fantastic to talk to people about data science, not through a screen. I've loved it. Anyway, today I'm going to be giving you a talk on machine learning engineering. It's got 5 parts. There'll be a brief introduction where I talk a little bit about me, a little bit about my company and machine learning engineering. There's going to be some low-level stuff on building a machine learning production system. Just, can I get a quick show of hands? Are there any machine learning engineers in the audience? Hello, machine learning engineers. Fantastic. They'll keep me right if I say anything that's wrong. So it's a role I've been doing for 6 months. I wouldn't say I'm an expert, but I think I know enough to give a reasonable talk. Yeah, so we're going to be talking about some low-level stuff. So hopefully, who here actually codes, likes writing code? Most of you, fantastic. I'm in the right room. I love coders. I got offered like a head of data role. I didn't take it because I still wanted to be hands-on. I still feel like, like Rocky. In the latest Rocky film, he feels like he's got some stuff in the basement. That's me. I still feel like I've got some code in me. I'm looking forward to sharing it. Then we'll talk about some machine learning production architecture, so kind of a bigger picture, and I'll also tell you why I love feature stores, but more about that later. And then there'll be some closing thoughts and some resources if anyone's interested. Yeah, so it does contain code, but you will code anyway, so it's fine. So if you want to follow along, we live in the age of the QR code, so my slides are available if you can see the QR code, and everyone's getting their phones out really good. There will be other points during the presentation where the QR code pops up. So if you want to follow along on my slides and check any of the links, you're more than welcome to. Everyone got that? I'm definitely a follower-alonger. Like, if I'm watching a Netflix series based upon a real event, I'm always kind of Googling the real event while I'm watching it. Okay, I think everyone's got that. Fantastic. So the introduction. So about me, I've worked most of my career in data. I've worked in government, I've worked in consultancies, I've worked a brief period, an ill-fated period, an event startup. I joined an event startup in February 2020 and got furloughed in March 2020. Yeah, you laugh, it sucked. But they were a great company, I loved them, they're called Add to Event, and they were so good to me. So I always give them a little plug. If you need something to add to your event, like a wedding or whatever, check them out, it's a great website and they're a great bunch of people. So my skills, machine learning, data engineering, cloud engineering, software and API development. That's what you get at consultancy. You get a broad range of skills at the expense of perhaps depth in any of them. And one other thing, my wife just shipped our first child into production 3 weeks ago. They're looking at this thing, yep, he's definitely an engineer. Her name is Merrin. I love her dearly. She's 3.5 weeks old. And there's quite a few reasons I'm telling you this. One, because I haven't had much sleep last night, so I'm really, really tired. 2, yeah, the presentation's not as great as I would like, so apologies for the fact that it's a bit bland, it's just white and text a lot of the time. And 3, she's going to be an engineer just like her dad, which is awesome. So, I don't profess to be an expert in machine learning engineering, but I have talked to a lot of people smarter than me, and I've learned a lot from them, and I've learned to kind of, I'm specking out Saint Gobain UK's machine learning system, and hopefully there's something for you here as well. Talk is aimed at data scientists, analysts, coders who want an introduction to production ML systems. There's also something for non-technical roles, and there's also I do like being an engineer, I do like well-written code, So hopefully there'll be some tips to allow you to write better code and start to learn the elements that go into a production system. So about my company, so Saint Gobain, as I said, they're huge in France. They're a multinational corporation, very, very focused in the building trade. They were actually founded in 1666 in Paris as a mirror manufacturer, but they do own a number of UK brands, the most famous of which is Jupyter. Anyone heard of Jupyter? The other ones are more kind of occluded, and you may not have heard of them, but they do have quite a significant UK portfolio. And they've got a reputation for being highly innovative within the construction industry, and now they're applying that to a lot of what they do digitally as well. In terms of AI, I would classify us as a maturing data science team. So at the moment, we are working with an on-prem infrastructure pretty much, based around the Cloudera stacks. We have a Cloudera system that's managed for us, and that encompasses Apache Spark, Impala, and Hive. We've recently made the jump to using Python exclusively. So we no longer use R because it's too difficult to have two systems being put into production. But we are moving to Azure early next year, so we're really looking forward to playing with all of those toys. One extra thing, we are recruiting a machine learning engineer. As with most people, I'm sure everyone who stood up in front of you said, yeah, we're recruiting. I appreciate Saint Gobain buildings, not quite as sexy as Deliveroo and all the crazy stuff that GSK are doing. But if you are interested, you'll get on at the ground floor. And I want to build amazing stuff. So if anyone is interested in the role, please come grab me during the break. So what exactly is machine learning engineering? So I've actually come up with a Venn diagram, and most of you will have seen the data science Venn diagram. And this is actually the slide that took me the longest, despite containing the least. And the way I would describe machine learning engineering is at the intersection of data science and AI, software engineering, and DevOps, and data engineering. So those are the three elements, I would say, of my job. A quick brief word on MLOps. Often people view MLOps as synonymous with machine learning engineering, and I think that's a bit of a false friend. I think it's a bit of a red herring because there's so much that goes into creating any production system, regardless of whether it's an AI system or a website or whatever. And kind of MLOps kind of makes you think about it all, or DevOps, MLOps makes you think that it's about containers, it's about CI/CD pipelines. When in actual fact, it's a lot of the time those concepts get abstracted away by your cloud platforms or your provider. So just a little word of warning that I personally don't think that those two are the same thing. So having been a kind of a data scientist and now has gone through the data engineering, software engineering, and now being a machine learning engineer, I feel confident in saying the person creating an algorithm isn't the best person to implement it. Data scientists will have the general data skills, and that's where the crossover is between data science and machine learning engineering. We both have those kind of core data skills. We take data, analyze it, manipulate it, pipeline it, whatever. But the data scientist is far more mathematically and statistically focused, and they will actually explore data and they will create models. Machine learning engineering is more data and software engineering. My job is managing data, building pipelines, and implementing models. And the lens through which I view that is creativity versus proficiency. Now, it's a crude way of thinking about it. It's not to say I'm not creative in my role, and it's not to say that data scientists don't need to be proficient. But I'm focused on building something for the ages, something really robust that's going to stand the test of time. Having created models myself, I know that it is a really, really creative process. There's no rule book on how to best do EDA. There's no rule book on how to, the way in which you feature engineer, hyper-tune. A lot of it is intuitive, and you learn it over time, and that's where the creativity comes in. So yeah, as a machine learning engineer, my favorite words are robust, slick, reliable. I use a lot of those kind of words in my job. Okay, and if you are interested in creative teams versus proficient teams, I'd recommend The Culture Code by Daniel Coyle. It's a really, really good book, and it delves into what creates a great team culture. And also, it has a section in there on creativity-based teams and proficiency-based teams. So, breakdown of my role, I would say I spend about 40% of my time data engineering, 40% of my time software engineering and DevOps, and actually only 20% of my time doing data science and AI. And that's because most of the time, the data scientist has done that for me, and it's about providing structure and order to what they've done. You'll also notice, now I know what most of you will be thinking here. You'll be thinking, oh my God, he's used a 3D pie chart. And the percentages don't correspond to the size of the pie. Well, there's a good reason for that, because working with data scientists and statisticians on a day-to-day basis, I'm only joking, I get on great. I really enjoy working with talented modelers and helping kind of take their work to the next level, and so that both them and the business kind of see the benefit of it. Yeah, so a little bit of light-hearted banter between machine learning engineers and the data scientists never hurt anyone. Okay, so building a production ML system. So notebooks. I don't hate notebooks, but so yeah, this is probably the most controversial element of my talk, and the reason I warmed you up with the 3D pie chart. I think notebooks are a fantastic creative tool. I'm not sold on putting notebooks into production. I know that many people who have spoken to you today will have put notebooks into production, and a lot of companies do, and similarly, all the cloud platforms enable you to put notebooks into production if you want. I personally am not a fan. The three main reasons are they have a hidden state due to non-linear execution, and that can mean that you get errors. So, for example, you spend all day working in your notebook, you close it down, you go back the day after, and you've deleted a cell that was stored in the history, and all of a sudden it doesn't work, or it doesn't work correctly, or it produces different results, and so on and so forth. They become disorganized and bloated so quickly. I know mine do. And they don't encourage software engineering best practices around testing and modularity, which we're going to look at in a little bit. And I've lost count of the number of times I've seen sensitive data committed to Git in notebook output cells. And there's people nodding. There's people here that agree with me. Yes. So I do want to be clear. I'm not saying you're wrong or anything like that. What I am saying is that opinion is divided, and I'm in the I don't think notebooks in production are a good idea. Okay, that's what I'm saying. And I'm not the only one. Joel Gruss, and he's a man far more brave than I. He actually went to JupyterCon in 2018, and he did a talk called Why I Hate Notebooks. I do advise you to, first of all, it's a really entertaining talk, even if you don't agree, and I advise you to check it out. But it is quite, as I said, it's quite a controversial topic, so just bear that in mind. And indeed, there was a little bit of a controversy between him and Jeremy Howard there around that, and Jeremy Howard has actually done a counter talk on why I love notebooks, and both perfectly valid opinions. I'll leave you to make up your own mind. So, 5 lower-level concepts of production systems that data scientists can easily learn. Now, these aren't sexy concepts. They're not particularly exciting, apart from the logging, because you can get covered output, but these things are really, really crucial in any kind of production system. So we're going to go through 5, and I'm going to show you some code. And I think, personally, it's possible to learn these 5 things in less than a day, easily, because they're not complicated concepts. They sound it, but so does everything until you get to know it. So they're modularity in packaging, configuration, parameters, logging, and unit tests. Has anyone here written a unit test? Ah, yeah. Okay, I feel your pain. I feel your pain. And yeah, another QR code. So if you come in late and you want to follow along on the slides, feel free to get your phone out. Oh, there's a couple of people. I knew there was a good reason I put 6 QR codes in the presentation. It also gives me a chance to have a fantastic. Have we all got it? Anyone? Okay, I think we've all got it. So, modularity and packaging. So it wasn't until my most recent role where I started, and none of the data scientists were actually in the habit of writing modular code. Everything was in a notebook, and the notebooks were huge. There was, literally maybe, 80 cells full of code and outputs and all sorts, and it was a real nightmare for me to pick that up and navigate it. The key to solving that is modularity, so that's creating modules with .py files, and they help you organize your code so that it's navigable by a human, so you can split your code up into, for a machine learning system, you might have an ingestion module with all the ingestion code in, a transformation module, feature engineering module, a model module, and maybe an evaluation module and a deployment module. And what that means is when someone else picks it up, they don't just kind of go, I can't be bothered with this and tack something on the end. It means they actually put stuff in the right place. Modularity occurs via PI files and directories with accompanying init PI file in the directory to mark it as a Python module. So again, it's not a difficult concept. You take a function, you put it in a PI file, and you put an empty init PI file in that directory. Voila, you've created a module, okay? And then you can then import that into your notebook the same way that you do other stuff. And I guarantee you it will improve your productivity, organization, and the reliability of your code. And down the bottom, there's a What's in it for me tutorial that's actually focused towards data scientists, teaching you how to kind of create that modular structure. Additionally, it's not here, but there is the cookie cutter structure that's actually really good. That's available on GitHub as well. Sorry, I forgot to put it in the presentation. Okay, configuration. So, and a configuration is something that was basically every piece of metadata that is likely to vary between deploys of your model. So that includes things like database locations, credentials, metadata storage, log locations, artifact locations, CSV files. And the idea is if you're working in a production system, you'll have your development environment, you'll have a test environment, and you'll have a live environment. And those three things will each have a different configuration. You'll be using different data sets, different credentials, different kind of output locations for your logs. And also, when if you develop on your local machine and then you have to move something into the cloud, you're going to start saving stuff in buckets or S3 buckets or cloud buckets or whatever, and databases and so on. So actually having setting the configuration up to begin with saves you a lot of time if you're going to go down that route. Additionally, it's sensitive, so you should never commit it to Git. And I've lost count of the amount of times I've seen sensitive information committed to Git that shouldn't be. So it's actually a really good way to kind of manage that sensitive data at the same time. We use a package called python.env to help us manage that. So if you look on the right, you'll see that we've got an example .env file, and that's where you would store your configuration. You would have different versions for dev, test, live, whatever. And then you would have a file in Python that would actually load .env with the env file and then unpack all of your configuration into Python objects. And you would also ignore that. Okay. Parameters. Excuse me, it's drinking Coke during a presentation with a microphone on that you can't move away from your mouth. So who here has ever, say you've deployed something to a cloud, and then you realize you have to change a value. So you change the value, you commit it to Git, then the cloud you have to rebuild it in the cloud and then rerun it, and the whole process takes something like 40 or 50 minutes. There's people nodding, yeah? This is why you have parameters files. And parameters are values in the application that are used or changed frequently. And that includes things like label codes and decodes, for example, train test sizes, model hyperparameters. So anything that is liable to change, if you can store that in a parameters file, it will save you that hassle of going through that pipeline every time you change something in your source code, having to rebuild everything. We store them in YAML files because YAML files are really easily readable, but you can use JSON or a .py file as well. And again, some code on the left-hand side. Again, this is the top one. This is what YAML looks like. It's really human readable. There's not, you don't have to put quotes in and everything. This is how you would store a dictionary value, and this is how you would store a list value. And here is how you would actually open it. So it's 5 or 6 lines of code, and you can have a parameters file. Again, not particularly difficult to learn. One extra thing, if you've got really important parameters, you should set those as a command line argument that can actually override your parameters file. Okay, my favorite one, the logger. I love the logger. So you know that when something goes wrong on your machine, you get an error message. When something goes wrong in production, you need a logger to log that error message so you can go and debug whatever it is that needs debugging. Now Python, has anyone here used a logger? Yeah, a fair few of you, that's good. Now Python does have an inbuilt logging module, but I don't like it because it takes ages to set up, and I find it really irritating. And I instead use a Python package called Loguru that does a lot of stuff for you. So it has colored log outputs by default. And the thing is, when you produce colored log outputs, it's fun. And people automatically think you know what you're doing, which is pretty cool. But there is so it's actually got enhanced debugging capability as well. So you know when, if you've ever had a function fail and you don't know where in your, so you've got 200 lines of code that you iterate through, you don't know where in those 200 lines it failed, you don't know what the parameters were at the function at the time of failure. Logguru gives you all that in the error message, which is really cool. Takes some getting used to because the error messages are in a different format, but once you are used to it, it's way better. And again, I've done a gist, so it didn't fit on the slide, bit of cheat. I've done a gist here that you can go to, so if you do want to have colored log files in your code, you can just nick this, paste it into your code, and it should work. Oh, where's my slides gone? Okay, oh, hang on. I'm also making do without my notes, so apologies if I ramble. The last one is unit tests. Now, unit tests are my least favorite thing about being a machine learning engineer. I hate them, I hate having to write them, but they are totally necessary. So they're a really basic type of test, and you use them on your functions and classes to make sure that those functions and classes are doing what you think they're doing and what they're supposed to be doing. As a general rule, you want 70% of your application unit tested. And we use a combination of a package called PyTest and coverage to execute our tests and to measure coverage. So up here, you can see this is a really basic function. So def my function y equals x times 2. And the test for that is basically what we do. We create a test my function, and then y equals my function 1, and then the assert statement that actually tests it. And that's all you need to do. PyTest will actually pick that up through conventions, and also you type PyTest v, and it will actually run the tests for you and give you a nice little printout telling you all your tests have passed, because my unit tests never ever fail. That was a lie, by the way. They always fail. And also coverage is really nice as well. It's another really automatic package. You wrap it around PyTest, and it will actually produce you a little report telling you what percentage of your code base has actually been unit tested. And a lot of people don't actually know about it. I think it's a really cool package. So that's 5 really simple concepts, and I think maybe I'm being overambitious, but I don't think those are difficult things to learn. And I guarantee you they'll make you a better coder and a more effective data scientist. 2 other resources that I would recommend are 12factor.net, and that's something called who's heard of the 12-factor app? Oh, a few of you. Sorry, I just broke their lights. Yeah, a few of you. I'd really recommend it. Most of what I learned this was the basis, the starting point for my learning about production systems. And it's plain English. It's written in a way that's easier for lay people to understand. And it lists 12 things that are really crucial, the best way to build production systems. The other one is martinfowler.com. Martin's site is brilliant. He's the guru on testing, and a lot of it was written years ago, and it still stands the test of time, and that's generally the sign of really, really good material. He also reviews board games. He's got a lot of reviews for board games on there, and sometimes I'll go on there to look up something about testing and end up procrastinating and reading about his board games. Okay, so machine learning production architecture. Anyone not got the QR code yet? Oh, there are a couple of people that haven't got the QR. So it's good that people are, because I'm slowly convincing you that you need this material in your life. I'm kind of brainwashing you, I like it. Okay, everyone got it, fantastic. So when I got the job at Saint Gobain, I hadn't been a machine learning engineer before. I'd done software engineering, data science, data engineering, and I figured, I was upfront with them. I said, it's not something I've done before. It's something I want to move into. I'm not the finished article yet, so I started before I started the role. I started reading about production ML systems, and yeah. So I'm just going to show you these for an example. This is the kind of stuff I was looking at. So this is an ML application architecture from Google. This is one from Azure. And this is one from AWS, and I still don't understand the AWS one because they're so complicated. And for me, it's actually a barrier. It was a really big barrier trying to look at, production systems to the nth degree, because that's not how we learn. We learn through picking up individual concepts and then forming the bigger picture ourselves. So what I'm going to do, and that was me, what I'm going to do is actually explain to you 5 concepts, kind of more high-level concepts, not the lower-level ones that are key in production ML systems. They're model pipelines, a feature store, and I love feature stores right now. They're the best thing ever. Deployment, monitoring, and orchestration. Ooh, model pipelines. So who here has built a machine learning model? In scikit-learn? Who here has used the scikit-learn pipelines functionality? Oh, a fair number of you. That's really good. So scikit-learn pipelines are in a really, really good way of ensuring that the transformations that you have that are required to take the data from whatever it looks like at the beginning to outputting in prediction, they're a really good way to ensure that that all ships together in a single model object. And we actually deploy with MLFlow. And MLFlow requires that, the models are built in this way. And when I joined Saint Gobain, the models weren't built in this way. So it meant a lot of rework to kind of spec out what the pipelines are. So this is what a model pipeline would look like. You've got, that you're checking and converting types, creating columns, imputing missing values, one-hot encoding, scaling, and then finally you've got a regressor on the end. So it's ensuring that all of those transformations are kind of grouped together so that when the model is in production, it starts at check and convert types, and you don't actually have to perform a load of transformations before giving the model the data. However, when you implement a feature store, and now the term feature store is another word for database with tables in, but it's specific to machine learning features. So those tables contained pre-cleaned and computed features that support production models and model development. So in our feature store, we've got kind of 2 types of tables. We've got a master features table. So when I joined, we had maybe 4 or 5 models that needed to go into production. And I'd say around about 60% of the data in those 4 or 5 models actually overlapped. So it was actually in all of them. And what we were, had we put those models into production with full pipelines, we would have been performing the same transformations across 5 different models. And that's not efficient. We have to maintain 5 versions of the same thing. And that's, it makes the pipelines inefficient as well. So by kind of abstracting that away and saying, well, actually, we'll just produce, we'll run the features on a batch overnight, we'll produce it in SQL, we'll manage it like it's a data engineering challenge rather than a modeling challenge, everything becomes a lot simpler. So we have the master features table where data scientists can just go, get features, start experimenting straight away without having to write a load of PySpark to join stuff together, which they hate doing. And then once they've kind of built their model, what we do is we create a smaller table that they can then use with the features specific to each model to support those model pipelines. And that means much simpler model pipelines. It means less unit tests, less documentation. It makes me happy, warm, and fuzzy inside, and a good feature store. And as I mentioned before, we use SQL pipelines for ours, and it's refreshed daily. Now, it has a number of advantages. I mentioned, we're not repeating ourselves across lots of different repos and models. The pipelines are much quicker to develop and execute. And also, one thing we have to be really mindful of is that we are moving to Azure next year. At the moment, most of our stuff is in PySpark. We've started to convert a lot of those model pipelines to SQL. But the good thing about SQL is that everywhere uses it. You don't necessarily need to have a PySpark runtime, a Python, TensorFlow installed with a specific package. SQL will generally run anywhere. And that makes it really easy for us to kind of say, well, actually, we'll just move that into our Synapse data warehouse. Or, we can run it, and we can even use it. I mean, if we've got online models, we want to create a smaller feature store on a really performant database for lightning quick latency. And we can use the same code. So SQL for your feature engineering pipelines is actually a really, really good idea. And if your SQL skills are rusty, I know mine were up until about a year ago. I would do select, star, from, and then write a load of pandas. It's really, really worth learning. I think it can speed up your workflow. And it's not fun. It's not as fun as Python, but it is necessary. OK, anyone used MLFlow? Yeah, a lot of you, fantastic. Lots of really cool technology people are using in this room. We used MLFlow for deployment for 2 reasons. One, because it's the solution that has most of the boxes that we want ticked in terms of a machine learning solution. Now, provided, as I mentioned before, if you created the model the right way, I've got to speed up a little bit, I've only got 10 minutes left. Provided you create the model the right way, deployment is as simple as a single command in the CLI. And most of our models are hosted on our Spark cluster. The ones that are online are anyway, and they're not kind of high volume. We hit them maybe 2 or 3 times a day. So it's not, we don't need kind of Kubernetes clusters and all that. But MLFlow will also integrate with Azure as well. It's got really good Azure integration, so we can just move stuff when we make that migration. And MLFlow's got loads of other really good functionality, parameters, experiment tracking, model registry and versioning, architect, so we can version the data in it, we can export logs in it, it does loads of stuff that we need. I did, just before I started, I did create an example. Oh no, you can't see it. No, I didn't, I deleted it. No, it's probably private. I will make that public when I get home this evening. But yeah, there is an example repository with Titanic data and all of the concepts that I've mentioned, and also, yeah, the MLFlow. And there's the official MLFlow tutorial as well, which is really good. And this is what MLFlow looks like. So it does actually log your experiments, which I think is really cool. Data scientists agree with me, so yeah. But it manages quite a lot of stuff for you, and it's quite easy to learn. It's quite a low, you don't need to code in a certain way the way you do with some frameworks like TFX and so on. It's quite lightweight, is what I'm looking for. Okay, so monitoring is something that we haven't really done a great deal of. As I said, most of our models are relatively simple. We have a mix. We've got a mix of rules-based models, simple machine learning models, and a couple of deep learning models. But most of these are refreshed every day. So monitoring isn't something we've actually implemented into our stack yet. But that said, it is really, really important. It is in our kind of pipeline to actually start monitoring our models properly. Now, there's 2 reasons we would do that. Checking the system works properly, and also checking for model drift, where the relationship between your features and what you're trying to predict drifts over time. And there are a number of great tools and platforms that do this, Seldon, Databricks, so on. But because we can only use Python packages generally on our Spark cluster, we've opted for a little package called PyDrift. And one of my data science colleagues was checking it out on Friday, and he says it's actually really, really good, and he's really looking forward to using it. So it does have a glowing recommendation from Ryan. Last up, orchestration. Anyone heard of Metaflow? Okay. Anyone heard of Airflow? Yeah, okay. So Metaflow is basically, if I had to describe it in one sentence, it's a cut-down, scaled-down version of Airflow for AI workloads. It's produced by Netflix, and it doesn't require a web server, and you can actually build DAGs with a single file, which makes it awesome as far as I'm concerned, because we don't actually have the facility to host a web server on our Spark cluster anyway, and it can actually orchestrate our SQL workloads for the feature store, which I love, and also our PySpark model pipelines as well. So we actually love Metaflow. I really do. You know, if you are looking for something, a simple orchestration system, Metaflow is really, really good. And it can execute Python code as well as CLI commands and SQL and do all sorts. It's really, really good. Well worth checking out. So my closing thoughts. So I've come up with 5 final tips for you if you are interested in being a machine learning engineer. So the philosophy I build is for everything is to build things for the ages. And that's, so like, say I have to set up a database to support a machine learning application. Probably going to need to do that more than once. So I'll actually write that as a script or a production piece of code that can be rerun over and over and over. I won't just kind of think, oh, I'll only do it once, because that's when holes start appearing in your kind of end-to-end pipeline. And you've got tools like Terraform, which make that a lot easier now anyway. And that makes everything reproducible, even your setup. Documentation. Is anyone here, who here has written a well-ordered README file? Not that many of you, okay. When you collaborate with other people, it's really, really important to document what you do. I did work at a place at some point in the last 3 years. I don't want to give away who they are, but they had a tool that was a huge repo, and there was no documentation for it. It was just unmanageable. And they said, you know, what do you think you can do with this? And I said, nothing. Don't know how it works. I don't know what I need to do where to put stuff. I don't know anything about it. You need someone to spend 2 or 3 weeks going through this, figuring out what it does, and writing the documentation for it. There was a video, but needless to say, the video didn't touch on any of the points that I wanted to know. And that's why documentation is so important. If you want to build stuff for the ages, documentation is the way to go forward. Bad documentation is better than no documentation. Okay, so even if you've taken the time to write something, that's good. And your bad documentation might be good documentation if it has pictures and diagrams in it. All too often, for machine learning systems and pipelines and so on, it's a visual thing, a pipeline of data, and there's no visual, there's no visuals in the README, and it's something that can make everything far simpler for someone like me who comes to your code to try and pick it up. Be explicit. Now, what I mean by this is, like, if you're importing a library, don't use import star, because it introduces invisible stuff into a notebook, and that really annoys me because I don't know what that stuff is. You've just imported a whole lot. You can overwrite namespaces. It's that kind of thing. Think about things from that perspective. Think about things from someone picking up your code would have to do. And that will include your future self, I guarantee it. And lastly, learning SQL is really a bad idea. No one wants to do it, but it will probably help your career. So resources and further reading. Joel Grush's talk, I mentioned that before, it's really good. It's filmed with memes and GIFs, and he's actually a good presenter and he makes some excellent points. He's got the slides there as well. As balance, Netflix have an interact notebook production ecosystem, as do Databricks. If you want to kind of come to your own decision about whether to productionize notebooks or not, that's a great place to go. 12 Factor app and Martin Fowler's site I've talked about. Very quickly, the Machine Learning Engineer newsletter. Now, my friend Alejandro, a chap called Alejandro Saucedo, I was having a beer with him about 5 years ago, and he started telling me about MLOps. And myself and our other friend said, "Oh, you just made that up. That's not a thing." And here we are 5 years later, and it's a huge thing. Everyone's talking about MLOps. And he actually, he was one of the first people to see the potential of it. And he's got something called the Machine Learning Engineer newsletter, which is amazing. He always produces really pertinent, really, really good articles as part of it. I highly encourage you to go and subscribe. He's a great dude as well. Does a lot of open source work, as well as alongside his day job. A comparison matrix for ML platforms. I see so many machine learning platforms out there, and I can't make sense of them. And some beautiful person has actually put all the machine learning platforms in a spreadsheet and explained all the bits and pieces that they do. Yeah, I need to buy that person a beer. And lastly, the awesome ML production GitHub repo, which is, again, contains great resources if you're looking to kind of get into the production space. Anyone want the slides? No? Okay. Fantastic. Okay, thank you for your time. Thank you for indulging me. Does anyone have any questions? Yes, the gentleman here.
So I've done some of the good stuff I've got there, but
Yep.
nowhere near all of it. And specifically, I've mixed up my config and my parameters, so I'm doing them all in the same
Okay.
Why do you separate them?
There's no hard and fast rule. I would say, generally, if you think something's sensitive, it's probably a config. If it's not, it's probably parameters. And there are some grey areas, stuff like column headings and things like that. You think, oh, but those are going to be in your code anyway, because if you're doing AI stuff, machine learning stuff, you can't really get around it. So I would just say use your judgment and err on the side of caution. Yes, Kian, hello, sorry. I think try and write tests that try and break what you've written is always a good starting point. For data and models, it is more difficult. It's a lot more difficult. It's not traditional system behavior where you're going to get an X, Y, Z out. Generally, I check types and I check calculations. And maybe like for stuff like for models, you can't test the model outputs for unit tests. So don't even bother trying. A lot of the time, the model unit test is this a model? And there's not really a great deal that you can do more with unit tests, but you might have other kind of specific tests around kind of more evaluation, really, than anything, I would say. So yeah, sorry, can't help there, Kian. Hello, gentleman with a moustache.
Yeah, I was going to build a bit on that, actually, I was going to say, because I completely agree with what you put there. I thought that was really good. But you were talking about, those 5 sort of software engineering things you could learn in a day. I think I would argue with unit tests, it's a bit different there, because, again, like you mentioned, it's not the easiest thing, and I think it actually, it takes a bit of getting used to. It comes back to you should think about in the design of your code as well the first time.
Yeah.
And how you're going to test it should come into that. And I think that, for me, is where I see a lot of issues come up.
Yeah, no, I get that.
You can write bad tests, right? You can only test parts sometimes, they're bad tests.
Yeah, no, I do actually, I completely agree with that. That's a really good point, a really good challenge. I would reiterate what I said to Kian is that you should be writing tests that try and break code and test edge cases, particularly with data. But I wouldn't classify myself as an authority on unit tests. And yeah, I mean, things like, I wouldn't write unit tests for an ingestion pipeline, for example, because it's too time consuming. I would have tests that run when you run the pipeline, like you can write in DBT, that actually say, is there data, does it conform to this distribution, and that kind of thing.
So that for me is, this is
Yeah.
something I'm quite hot on at the moment, is I think there's too much overlap between, so in an ML system you have three sets of testing.
Yeah.
You have your unit testing around software, you have your data testing around QA and monitoring and stuff like that, then you have your ML stuff around your marketing homework, your kind of your model validation, stuff like that. And I think there's too much overlap a lot of the time between the three. And you need systems that try and test it and you can't decouple them. And I think we've come up with a way of decoupling them and having them as separate things.
Okay, I would like to see that.
Yeah, I want to write blog posts on it, but yeah,
Fantastic.
this is something that's not quite set out.
Yeah.
We haven't worked out the optimal way of doing it. And
Yeah.
I think this is
I would say
issues come up.
this is an evolving field, and if you've done that, I think a lot of people will find that useful. So thank you. More questions? Yes, chap. Sorry, chap.
I really enjoy your talk.
Thank you.
I also lead the machine learning engineer team in GSK.
Oh, okay.
I would like to know you share a bit more about monitoring, because I think it's really challenge, and from your talk I didn't see anything. If you really do in your project, would you mind to share a bit more, or we can talk offline?
Yeah, definitely. I was hosting a GSK talk earlier, and it looked really cool, the stuff you were doing.
And also, I know about for my team is also hiring you.
My team's better. Don't you go vote for him. Okay, how much time do we have? Okay, I've got time for one more question. I'm really sorry. If you want, you can come and grab me. I'm going to be here. We'll go with over this side. Sorry, I haven't asked anyone over this side. Oh, yes, I have, but yes, sorry.
Very quick one. On the unit tests, we've seen free stuff on that. Have you ever seen test-driven development?
Yes.
And is it applicable to ML?
You can do it. I think it's one of those things that you either love or you hate. I don't like it. I know I should, but I don't. So if you want to be really cool, test-driven development where you write the test before you actually apply it to live data, and that's quite a good way. But yeah, it's not I've tried it, didn't really get on with it. Got time for one more maybe, so the chap behind you?
Just a more general question.
Is it about unit tests? Yes!
What data science do and structure
I can't really talk about it. We have a very, very tight security. I would say a lot of the stuff that's been discussed in some of the talks today is the kind of stuff that we're working on. But yeah, I've been told to err on the side of caution before telling you the kind of the content of our project, so I'm really sorry. Okay, thank you all for indulging me. I hope you enjoyed the talk and got something out of it, and I look forward to seeing all your unit tests. Thank you.